M.S. Ramaiah University of Applied Sciences.
Hi students, let us understand about 8086 microprocessor. 8086 is a 16-bit microprocessor. 8086 has a 20-bit address bus, can access up to 2 power 20 memory locations. It can support up to 64K input-output ports. It provides 14 16-bit registers. It has multiplexed address and data bus. 8086 is designed to operate in two modes, minimum and maximum mode. It requires plus 5 volts power supply. It has 40-pin dual inline package. There are various methods by which a microprocessor program can be executed. A program can be physically executed using hardware kit by entering through keyboard or by downloading the hex file using Talk software. The program can be executed virtually without a physical processor, and output can be seen using MASM, TASM and emulator x86. Now, let us understand the various parts of 8086 kit and learn how to use it. This is the 8086 kit. This kit is used to interface and test various programs, interfacing kits, etc., and thereby developing an application. This kit consists of various connectors CN1, CN2, CN3 and CN4. All these connectors are used to interface various peripheral devices and interfacing kits with 8086 kit. There are two D-type connectors, one male and the other female. One is used as serial port for communication and other is used for connecting power supply. The dip switch at the bottom of the kit is used to select various modes of operation of 8086 kit. There is a small battery unit which is used to power various components which require power even when the power is turned off. The LCD display is used to display the operation status, memory contents, characters entered in the keyboard, various registers, etc. There is a small port just above the LCD display which is used to vary the intensity of the LCD display. The USB connector is used to connect the keyboard to the 8086 kit. Keyboard is used to enter program into the 8086 kit, navigate between the different modes and execute the program and to see the result. The reset button resets the 8086 kit and the kit restarts from the beginning. The non-maskable interrupt button is used to create an interrupt. There are several jumpers in the 8086 kit which are used to select various modes of operation. The position of these jumpers are changed based on the experiment to be conducted with reference from the respective study card. Normally, the position of these jumpers are unchanged for most of the experiments. Now, let us learn the procedure to communicate with 8086 kit. Connect the power supply. Connect keyboard to keyboard connector. Switch on the power supply, press reset button. Make sure LCD display unit shows the program commanding. Start to assemble the codes using keyboard. Steps to execute the assembly programs. Following steps explains the program execution flow in 8086 trainer board kit. Type A. Enter. Assembler mode. Type SG0. Enter. Segment clear. Type LC. Enter. Label clear. Type DA. Enter. deassemble and assemble. Type the assembly language program ALP. Type N at int3. Enter. Type N at exclamatory. Enter. Type EX. Enter. Exit from DA mode. Type G, A star. Symbol appears on display and then enter the address location from where the program needs to start. Example 4000H. Press R to examine the register, E to examine the byte, W to examine the word.
Dear students, today in this session we will be studying about how the programming of microprocessor is done using microprocessor kit. So the components required for this experiment are keyboard, microprocessor kit and power supply. Before looking into the experiment, let us know the importance of each components used in this experiment. Keyboard. The keyboard is used to enter the assembly language program into the microprocessor kit, and the highlighted keys are special keys which are used to enter the command into the microprocessor kit. Microprocessor kit. This is the microprocessor kit which consists of the central processor as 8086 IC, which is a 16-bit processor which has 16-bit ALU. It has 40 pins. All the pins are brought out towards the left for external connection. Looking into the memory section, it has odd bank and even bank of ROM, and it has 32 kilobytes of RAM and 32 kilobytes. Totally it has 232 kilobytes, that is 64 kilobytes of RAM. 8251 IC is for serial communication, 8259 IC is for interrupt, and 8253 IC is for timer. The pins of timer and the interrupt are brought out here for external connection. It has two 8255 IC and these are for programmable peripheral interface. These pins are brought out for external connection here, and this IC pins are brought out for external connection here. Serial communication is done using RS-232. So to connect the external pin, we have this serial communication port. This port is to connect the external power supply. This blue color is the reset pin, and this is NMI pin, which is non-maskable interrupt. So this USB connector is to connect the keyboard externally for programming. This is a LCD display. This is dip switch, which consists of 8 pins. Amongst the 8, 1 and 7 will be on for keyboard connection, and 1 and 5 will be on for serial communication. This is a power supply which consists of 5 volt supply, ground, plus 12 volt and minus 12 volt supply. Behind there is a knob provided in order to connect it to microprocessor kit. Now let us begin the experiment and let us do the connections first. Let us now connect the power supply to the microprocessor kit. Let us now connect the keyboard to the microprocessor kit. Let us now switch on the power supply. When you switch on the power supply, this message will be displayed. First, press reset in the kit. Type A, enter, so that it goes to the assembler mode. Then type SG space 0, enter, which means that segment clear. Then type LC enter, which means label clear. Then type DA space from where your program has to be started. That memory location needs to be entered here. Now my program will be starting with the memory location 4000. Then give enter. DA means disassemble and assemble. Then type N. N means next. So till you get this symbol, @ symbol, you need to type N. Then give space and start typing your program, assembly language program. Now let us type a simple program, assembly language program of adding two 16-bit numbers. In order to add two 16-bit numbers, first we should move the numbers into the register. Let us move the number into the register, that is move space AX, comma 1111. Now 1111 is a 16-bit number which is moved to the register AX. Give enter. Then go to next N till you get that @ symbol. Then move BX, comma 2222. Enter. Give N till you get @. Then the add instruction has to be given AX, comma BX is to be given. According to this instruction, whatever the contents of AX and BX is present, both will be added up and will be stored in AX register. Give enter. Then give N INT 3, which means interrupt 3. Enter. Then give N, then shift 1, so that you get this exclamatory mark. Enter. Then give exit EX. So it comes out of the assembler and disassembler mode. Enter. As soon as you get this star symbol, give this G, which means go. Now you need to mention the address location from which your program has started. Give 4000. Enter. Now we need to check the result. The result is present in register A. Press R to see the result. Now the result is present in the register AX. So press E so that the accumulator register is displayed and the result is 3333. Since we have added 1111 plus 2222, the result is 3 and it is stored in AX register. This is how the programming is done using microprocessor kit. So the commands remain the same and the ALP, that is assembly language program, changes. So the arithmetic and logical instructions like addition, subtraction, multiplication, division of 8-bit, 16-bit and 32-bit can be done using the same procedure.
At MSR UAS, we spark your imagination unlike any other.